Okay, I'm going to go over force summations real quick, and I have a lot of kids that are confused about this, so I just want to kind of go over the basics of it. So we know that net force equals mass times acceleration. So if I have a ball that is falling through the air, and let's ignore air resistance, so it's going to have a force of F of g on it, or mg, sometimes I call it mg, sometimes F of g. There's no air resistance on it, so there's no other forces acting on it. So if I do a force summation of this, I would combine all forces acting on it, which is only one, and that is my net force, and so that equals mass times acceleration. But if I have a ball that is falling and I'm not ignoring air resistance, so I have F of g on it, and let's say I have the force of air resistance on it. Now I have two forces acting on it, and they're in opposite directions, so I'm going to subtract them to get my net force. So my net force is a summation of all of my forces. And if they're in the same direction, I add. If they're in the opposite direction, I subtract. So my summation here would be the air resistance force minus the force due to gravity equals ma. So this is my net force, and net force equals mass times acceleration. So when you're getting your net force, it's kind of like if you're trying to get your balance on how much money you have altogether. And if you had a checking account and a savings account and a credit card account, you would add your bank account and your savings account together because they would be in the same direction. But you would subtract the balance that's on your credit card because that's in the opposite direction. And once you added and subtracted all those balances, you would have your net balance, how much money you actually truly owned. And that's what the net force is. It's just taking all the forces acting on an object and adding or subtracting them. Okay? So let's say I have another object. Let's say we have a box on the floor, and it's being pushed in this direction, maybe by an applied force. Somebody's pushing it in this direction. It has friction acting in this direction. It has mg, or F of g, whatever you want to call it, acting down. And it has normal force acting up. Okay? If I do a force summation here, I only summate the vertical forces or the horizontal forces. I don't just put them all four together. Okay? So vertically, I'm going to say the total vertical forces, or maybe all the forces in the y direction, are equal to, I have one going up and one going down. So Fn minus Fg, that's my net force, and net force equals ma. And if your acceleration is 0, for example, there's 0 vertical acceleration here, this number 0, I can set everything equal to 0. My net forces in the horizontal direction, or the x direction, are equal to Fa minus F of f. We only have two acting horizontally, and they're in opposite directions, so I subtract. And that equals ma. Again, if this is moving at a constant velocity, I could mark this out and put 0 in its place. If there's an acceleration, I'll leave it as is. Okay, another example. Let me go ahead and switch out pages. What if I have a box on the ground with a rope tied to it, and somebody is pulling on it? Let's say there's an applied force in this direction. Okay, and then I have my F of g down. I have my normal force up. I have some friction force. Now if it says it's a frictionless surface, then this force isn't even there. Okay, so that's my free body diagram. And again, I only summate the forces in the vertical direction, all by themselves, and then I summate the forces in the horizontal direction. Well, this force is not in the vertical or the horizontal direction, so I have to break it into its components. So it has a horizontal component. Let's call it Fa x. And then it has a vertical component. I can draw it right here, or I'm going to pick this up and just put it over here. because I always like to have myself a nice right triangle. Okay, so I've got my x component of this force and I've got my y component of this force. So when I summate my vertical forces here, I've got 2 going up. Now when I break this down into its components, it's like it's not even there anymore. And I have these 2 forces acting on this object. So I've got 2 forces going up and 1 force going down. This is like your checking account and your savings account, and this is your credit card account. So to summate those forces, I would say Fn plus the vertical component minus f of g. Add the forces that are in the same direction here and then subtract this one. And that equals ma. And if there's no vertical acceleration on this, let's say somebody's pulling this and it's moving it to the right, but it's not accelerating vertically, I can set that equal to 0. For my horizontal summation, I have this one going to the right and this one going to the left. 2 forces acting on it, so I have the horizontal component of the applied force minus the friction force. They're going in opposite directions, so I subtract, and that equals mass times acceleration. Okay, so that's just kind of a basic example of how to do these force summations. You just need to take into account all the forces that are acting on an object and then summate the forces. And you don't mix vertical with horizontal on the same object. You'll do 2 separate summations.